reason I got my note sheet up here as we start is a lot of the same things that you did yesterday with equations, if you've done any examples yet. If you haven't, that's okay. Maybe you're waiting to see how some of this other stuff goes to see what you want to do. But my opposites that I'm going to be doing today are going to be the same. And I'm going to add a couple of generalities here to our inequalities as we do it too. So hopefully by the end we get a note sheet that's organized and very useful when we get to the final. But for now, all right, so inequalities, couple of things for us to remember. We're still doing the opposites. I'm going to apologize in advance. I wanted to get my graphs down here, but they ended up here. So a lot of the time, I'm going to rewrite what I see for my expression so I have a little more room to work with. So here, just like yesterday, with the equations, the goal, get the variable by itself. How are we going to undo the -9? Add it. The thing to remember with inequalities that's so critical is I can't switch sides on things and just randomly do it. So as I'm recopying this, it's critical that everything is being left alone that I haven't done something with. And once x is alone, I've got that part done. But here's the part now that I'm going to need to remind myself of how this works. So, first thing I got to pay attention to, what sign, what symbol am I going to be using, depending on the arrow. So, if I have an arrow that's greater than or less than, we're going to be using an open circle. If I've got an arrow underneath it, excuse me, a line underneath my arrow, it's going to be a filled in dot. So I see arrow under, so I know filled in dot. Okay. As long as your variable term is on the left, that's why I said it's important to not touch it as we're doing this. I can just follow the arrow. This says x is greater than, and the arrow is going to the right. And so that's what I'm going to follow. And I'm going to make the arrow go to the right. And I'm good. So, as I'm looking at some of these, nothing too bad's going on. So, I do want to take a look at a couple of twists that can come in, though, so we can hopefully avoid confusion, frustration, any of those things as we're taking a peek. So let's jump down to 6. I am going to do a distributed property one. I'm just picking a different one than the first one. And just keep reminding yourself, we're trying to get that first part alone. And do I want to do? Yeah, I'm going to rewrite it again. Hardy learning things as he goes as well. Okay. So I'm going to keep doing my opposites. I see the negative one. We're going to plus. Today I'm going to try to keep the problems to a minimum so we can have more time for me to get around and talk with people about some stuff. Okay, fraction. Fractions divide. How do I undo divide by 9? Multiply it. And a quick discussion that we had yesterday. On the side where the division is, you're not multiplying the 9 to the b. You're just using it to cancel that out. And negative 1 times 9 is negative 9. So I go back through my couple of steps. I go, okay, here's negative 9. Line underneath. So it's a filled in dot. And b is less than, it's pointing at b. So we're going to go left. The one special case that we deal with when we're doing our inequalities is if we've got a negative stuck to our variable term, which is what we're going to look at here. So number 7, the first thing I notice is I got some distributing to do. So I'm going to distribute my negative 2. I'm going to multiply my negative 2 to the n, and negative times negative is positive. I don't want to put minus a negative there. That's just going to confuse me. So parentheses going away is my first priority. Once I have that, the goal is the same. Get the variable term alone. Undo the things that aren't in the box. So I get to this last step, and you're like, okay, this isn't really that abnormal from what we've been doing. But if to solve my problem at any time, I have to multiply or divide both sides by a negative. Okay, if we multiply or divide, I'm going to put both sides here, by a negative, we're going to flip the arrow. This might be a good thing to put somewhere on the note sheet. We might do that when we get there in a moment. So what I mean by that is I'm dividing both sides by a negative. This inequality arrow flips. Everything else, we just do what we do. Those divided, the n stays here. The arrow flips. And I'm to my answer. And everything else is still the same. Go to negative 10. It's or equal to. It's a filled in dot. I need to find a non-filled in dot one to do next. And n is greater than or equal to. And we get that set. For my 8 requests, 6 is like not entirely identical, but pretty darn close. So I would try following 6 to do 8. You're still going to move that 9, that positive 9, you're going to move to the other side. And then you're going to undo the division like we did in 6. But as I look at these, and I'm doing this on purpose, there's certain things that kind of repeat and show up because they tend to show up again when you get to the final. And other things that we're going to see that aren't necessarily going to do that. So let's see here. I'm going to go ahead a little bit. I might come back to a couple of these, so give me a little bit of patience here. We're going to head over to the next page. And I want to do... I'm going to dot the ones that we want to play with here. Okay. So solve the compound inequality. There's more than one. And graph the solution. Okay. I'm going to do these in different colors to kind of make everything show up a little bit easier. Has the process changed since there's 2 of them? No. No, all we're doing, we're still, yeah, that's good. So I undo my minus 2, I add my 2. I undo my multiply by 5 by dividing by 5 and get my solution. And then I do the same thing over here. I want to get p alone. I'm minusing 8. So you're like, okay, so now what? It's like there's two different graphs going on. That's true. So if I look at this, I go, okay, so p is less than 4. Hey, no line underneath this time. Open circle. This says the arrow goes left. I'm just going to get it started here. I do my other one. So I'm at -8. With an open circle. P is greater than. The arrow's going to go right. Now here, I don't want to leave it this way. If the arrows are coming together like this, it means that everything between my two circles is the answer. And I want you to show me that. So if the arrows look like they're on a collision course, do the collision course, okay? But stop where those two endpoints are at. So anytime you see "and" in the middle, that's going to be a key on what this graph is going to look like. And here's the cool thing. These two problems we're going to do the exact same way, because when it's a big 3-part inequality, it's basically like I took this and I smashed it together. So check this out. Well, how am I going to do this? I mean, okay, if my goal is to get x alone, but now there's stuff going on to the left, there's stuff going on to the right, there's stuff going on in the middle. We're trying to get x alone in the middle, so whatever's hanging out with x in the middle is what we need to undo. So if I undo that +4, I got to do it on all 3 sides, because now that there's 2 arrows here, I got 1, 2, 3 parts of this. So it's a little different. Those go away. So I subtract my 4 to all 3. So whatever gets done to the middle gets done to all 3 parts. We got to divide by 8. Okay, we're not dividing everything by -8, so no flippage. No flippage. So you're like, okay, Harvey. Now this is where life gets interesting. Because normally we just arrow follow. So you're like, wait. So am I going to have an arrow going left at -6 and another one going left at 5? No. This is why I want us to understand that this is an and statement. If it's an and, the 2 points are going to come together. You're like, well, how is that true? So let's see. Okay, x is on the left here. X is less than 5. So here I am at 5. Okay, x is less than. I got it. This is the part that's a little tricky, though. Notice the arrow was pointing at x when we went left. But the arrow's not pointing at x when I look at this side. It's eating the x. It's saying you're greater than I am. So when I go to -6, and -6 says I am greater than you are, that actually comes back. So if what you're wondering in your brain is, okay, so does that mean every time I see a 3-part inequality like this, a big one, that I'm coloring in between the 2 points? The answer is yes. That's exactly what you're doing. So that one, might want to make a note of. We might have to do that in a minute. One more weird compounder here on this page. Why did I just do 14? I wasn't going to do 14. Well, what the heck? Well, now I'm doing 17 because I did that already. We can whip through this a little bit quicker, though. Just a little bit. You're like, but Hardy, it's just like the other one. Why are we doing another one like this? Well, because there's something special going on here. So I look at my other one, and I'm like, okay, I got to get rid of this positive 6. So we can undo that with minus. Positive 6 and negative 6 or minus 6 would cancel. Again, use the calculator if need be on some parts of this. That's true. So yeah, just because we're subtracting 6, there is no flippage involved, at least not yet. But now I get to the last step like I was doing on this one, where we're going to divide. But this time it's a little different. Because we're dividing everything by a negative. If you divide everything by a negative, you've got to flip the arrows. So when I divide these, negative divided by negative is positive. But the arrow flips. That gives me x. Dividing by a negative, the arrow flips. You're like, oh. So is that going to screw up my graph? Because now the arrows are both going to the right instead of going to the left. Or do I do the same thing? And the answer is you do the same thing. It seems strange. It's true. So at 4, we're going to have a closed circle because it's or equal to. At 2, we're going to have an open circle because there's no line underneath. But the rule is still the same. I'm still just coloring in the middle because it's a compound and large inequality. If I know the basics, I'm going to be okay. Yeah, we got to be cautious. And so, I believe I only got one more thing I'm going to throw your way. I'm just checking before I get there. Okay. 18. What's the difference? We're doing or. Okay. Or the graph's going to look a little different. Let's do this. We'll break these into pieces. The note sheet we're making, absolutely, that's what we're making it for. So for each one, I want to get r by itself. I undo whatever's with it. I'm adding 6. Right, you only are going to flip your arrow if you're dividing or multiplying both sides by a negative. But both sides, not every time we see a negative. Only when we're doing that. So I undid my positive 6. I'm going to undo my multiply by 7. So you're like, okay. Now it says or in the middle. So what? Well, let's see. We're back with 2 separate ones so we can follow the arrow sum. R is greater than or equal to -2. So, -2, closed in dot, because of the line underneath, or equal to. Greater than goes to the right. All right. Or R is less than -5. So, -5. no line underneath, so it's an open circle. And if I follow the arrow for less than, whenever you're doing or, your arrows go out from each other. They both start with O. Or goes out and goes in. That's going to be an excellent thing for us to stick on our note sheet here in a moment to kind of help us to see how this works. So you're still noticing, though, it's mainly just equation solving with a little bit of arrow work. Just a little bit. And so as we wrap up for today, and then like I said, we're going to add a little of the note sheet. At least I'm going to add it to mine. When I get to the back and I get down a little further here, there's one last section. It says write an inequality for each graph. Here's what we're going to do. Yes. So here, I'm going to have x. Watch the direction the arrow is going for your graph. That's the direction your arrow is going to go. Look to see if your circle is open or closed. If it's closed, we'll put a line underneath. And where's the circle at? That's it. Follow the arrow. Closed circle, we put the line under. Open circle, we don't. And then just put the number the circle starts at. That's not bad for being able to write the inequality. Last one. You're like, are you really serious, Hardy? Is this really the last one? It really is. Draw a graph for the inequality, like we've said. There's the number we're starting at. This tells me if it's an open or a closed circle. There's no line underneath, so it's open. And then just follow the arrow. And you're good. So if I was making a note sheet right now, and like I said, I'm going to have more next week if you're going to change something up. If I'm going to inequalities, I'm writing a couple of things. I'm going to write I'm going to remind myself the difference between open circle and closed circle. I'm going to do that before I get going. I'm going to remind myself what direction the arrows go, depending on what direction the arrow is pointing towards or for x. And maybe I'm going to put something in there if I don't think I'm going to remember about the whole if I multiply or divide by a negative. Maybe I even copy one of those problems into my inequalities section. So I've got that example there, not only of a problem, but what happens when I have the negative. If I have those things down and my opposites, inequalities aren't going to be bad either. But like I said, I'm trying to keep mine really basic and open right now. So when we get towards the end, I can know exactly what I want to put in those slots. But if you see a problem, I heard a couple of you talking as we were going, that you're like, yeah, that kind of is going to tell me a lot of stuff. So maybe I want to have that, in here. So maybe you get a problem like 17 where you're flipping the arrows and stuff, and you're going to want to do that. Oh, I didn't even do that. Let me do that too. Maybe I want more help. That should be R. On what the graphs look like. So maybe I want to see if I see and, I know the graphs coming together. And if it's or, I know my arrows are going out when I'm doing things like that. But again, the thing that's going to be the best for you on making sure this goes well, the note sheet helps, yes. the practice sticking these ideas into your brain is going to help even more, because then you're going to know exactly what you need on here to help and what you already know. And if you do those things, you're going to be successful.